अस्सलाम वालेकुम। समद यासीन, लेक्चरर केमिस्ट्री सेकंड फिज़िकल केमिस्ट्री बीएस स्टूडेंट्स। आज का हमारा टॉपिक केमिकल काइनेटिक्स के चैप्टर में सेकंड ऑर्डर रिएक्शंस। स्टूडेंट्स, सपोज two reactant A and B are reacting together to give us product. So there can be two situations that A and B have the equal concentration, or the other situation is that A and B have the different concentration. So we have to find the second order reaction equation for two different conditions. First we will find for the second order reaction equation with equal concentration of reactant. Suppose, as you are seeing that A and B is reacting together to give us product, let us say that A and B both have equal concentration, A and A mole per dm cube. So when the reaction is not going to start, time is equal to 0, product is going to form. Now the reaction is going to be started at the time t, x amount of product is going to be formed. So this x amount of product is subtracted from the reactant. The remaining concentration of reactant is A minus x and A minus x. So rate of reaction at the given time t is directly proportional to the product of the concentration of the remaining reactant at that time. So we can write the law of mass action as dx our dt is equal to k a into b. A की अमाउंट भी सेम है a minus x, सेम b के अमाउंट a minus x. So dx over dt is equal to k into a minus x whole square. Here k is rate constant, as you know. This equation tells us the speed of the second order reaction, how second order reaction is going to be progress. Now actually we want to find such a equation in which we have to know that given time at t what amount of product have been formed and what amount of reactant have been left. So for this purpose we have to integrate this equation 1. So as you know, before integration we have to separate the variables. We take the variables to the left hand side and time on the right hand side. So equation will be dx over a minus x whole square is equal to k dt. Now put up the integration sign. Before the variables, constant will be outside the integration. So as a result, dt give us the result t and plus c constant of integration. Now what is the result of dx over a minus x whole square? Students, it is the rule of integration formula that if any variable square dx is integrated, then it will be solved as power of that variable minus power of that variable plus 1 divided by the same power plus 1. For example, here a minus x, when going to the upper side it will be minus 2 power, so minus 2 power plus 1, same minus 2 plus 1 is going to be divided and minus 1 is the multiple of integration over here. So as a result you will see that a minus x raised to power minus 1 over minus 1 into multiple of integration minus 1. So as a result of this you will find the final equation is 1 over a minus x. Minus 1 is going to be cancelled and minus 1 power is can be written in the form of 1 over a minus x. So final equation is 1 over a minus x is equal to kt plus c. Now we have to find the this integration constant. For this we have to put up the initial reaction boundary condition when time is equal to 0, product x is equal to 0. So as a result you can see that c is equal to 1 over a. So put up the value of c in the equation 2 and the equation will be formed 1 over a minus x is equal to kt plus 1 over a. So it is a straight line equation, y is equal to mx plus c. So you are going to form a graph between time, which is independent variable, against a 1 over a minus x, which is dependable variable. As a result of this, a straight line passing through the origin will be formed. So no, actually straight line does not going to the origin, it will intersect the y coordinate. So slope can be found and slope is equal to rate constant K and intercept is 1 over A. Now slope can also be found by the tan theta value. Now students, we are going to rearrange this equation 4. As you can see, we have taken the concentrations terms on the one hand left hand side. 1 over A minus X minus 1 over A is equal to KT. We are going to take its LCM. Final form of equation after LCM will be A minus A plus X over A into A minus X is equal to KT. A and A is going to be cancelled. As a result, the equation is transformed into the equation number 5 as X over A into A minus X is equal to KT. Here the equation is also straight line equation, equation number 5, but y is equal to mx plus c. Either here the constant c or intercept is 0. Now we are going to draw the graph between time as a independent variable and x over a into a minus x as a dependable variable. So the straight line passing through the origin will be obtained. Now the intercept, as it line is going to intersect into the origin, intercept will be 0, and the slope can also be found as a rate constant K, which is equal to tan theta. Now unit of next heading is units of second order rate constant. Now we are going to write the second order rate constant equation, equation number 5, x over a into a minus x is equal to kt. Now we are going to find the rate constant, so k on the left hand side, t is going to right hand side, and put up the values of the concentration x a into a minus x. X, a and a minus x all have the concentration unit mole per dm cube. As a result, one concentration term is cancelled from above and below side, and one which is present below the equation, it will go upper side, so the final unit will be dm cube per mole per second for the second order rate constant. half life period of rate of or second order reaction. स्टूडेंट्स, सेकंड ऑर्डर रिएक्शन का हाफ लाइफ पीरियड आप कैसे निकालेंगे? ये उसी तरीके से है कि आप जानते हैं कि हाफ लाइफ वो टाइम पीरियड है जिसके अंदर इनिशियल रिएक्टेंट की 50% अमाउंट कंज्यूम हो जाती है या ख़त्म हो जाती है. सो इक्वेशन नंबर 5 kt is equal to x over a into a minus x. We are going to find the half life period, so t will be separated on the left hand side, and equation will be 1 over k x into x over a into a minus x. Now put up the x as a by 2 and t is t 1 by 2 या t half. Now t half is equal to 1 over k. I am putting the value of a by 2. You can see that the final form of equation will be 1 over ka. 1 over ka is showing that half-life period of second order reaction is inversely proportional to the initial concentration of reactant. It means that if we are going to take the bigger concentration of the reactant, then the half-life becomes shorter, or the reaction could be completed in shorter span of time. Now we are going to see some examples of second order reaction. For example, hydrolysis of ester by some base sodium hydroxide to form sodium acetate and ethanol is an example of second order reaction. Base hydrolysis of ester is a second order reaction examples, and the progress of the reaction can easily be studied volumetrically. You have to find out the amount of sodium hydroxide consumed at the start of the reaction, then at the different time interval of the reaction you will see that the amount of sodium hydroxide consumed is going to be decreased by the every movement. So to find out the amount of the sodium hydroxide, you can titrate it with some standard acid. So you can draw the graph by the time and decreasing concentration of sodium hydroxide, and you can see that the straight line will be formed, and by that slope you can find out the rate of the reaction. Now students, second order reaction with different initial concentration. Now we are going to see the second case of second order reaction where different concentration of reactant A and B are going to be reacted to give us product. Let us say that A reactant have the small a mole per dm cube and B reactant have the small b mole per dm cube of concentration when they are going to be reacted. So at the start of the reaction, when time is equal to 0, no product is going to be formed, but the reaction is started, time is equal to t, then x amount of product is formed, it will be subtracted from the reactant. So remaining amount of reactant A will be A minus x and remaining amount of B will be B minus x. So now we can write the rate law equation. Dx over dt is directly proportional to the concentration of reactant present at that time is equal to A minus x, B minus x, and when we are going to replace the proportionality sign with constant, final equation will be dx by dt is equal to k into A minus x, B minus x. Here k is the rate constant. Now again this equation is going to tell us how much is the speed of the reaction, or how or what is the velocity of reactant to convert it into product. But we are interested in such a equation where we can find out what amount of reactant is remaining and what amount of product has been formed at any time interval t. For this purpose we have to integrate the equation as we have done before. First separate the variables. Now after separating the variables, putting the integration sign, we can see that right hand side give us the same result. Dt is going to integrate, give us the kt plus c constant of integration, but on the left hand side there is now little bit difference from the previous experience. We have learned that in that case there are the two reacting species which have the different concentration and they are going to be multiplied. Now they cannot be solved by the simple integration. We have to follow the path of partial fractions. So what is partial fraction? Partial fraction we can do of the left hand side of the above equation. We can split the above equation according to this formula: 1 over A minus x into B minus x is equal to A over A minus x plus B over B minus x. So A and B are the constant which are going to be determined in the partial fraction equation. Now you are going to take the LCM of A minus x, B minus x, and after solving the equation you can see that after taking after seeing the equation formed by the taking LCM and solving it, it have the same denominator on the both side of equation. These can be cancelled out and the above equation can be written as 1 is equal to A into B minus x plus B into A minus x. So in order to get the value of A and B, which are the constant which and its value must be determined, we put the we will take A minus x is equal to 0 and B minus x is equal to 0 one by one, and then finding the value of A and B. So let us suppose that first we pick up the A minus x is equal to 0, then x is equal to A. Now put the value of x is equal to A in equation number 4. Now when we put the equation for x is equal to A, equation will be 1 is equal to A into B minus A plus B into A minus A. A minus A will factor will be cancelled, 0, and remaining factor will be A into B minus A, and it can be written as minus A into A minus B. After multiplying with the minus, A is equal to minus 1 over A minus B. Similarly, now we will take the B minus x is equal to 0. Here x is equal to B. Then again put up the x is equal to B in equation number 4. Now this time you will see that the A into B minus B factor will be going to 0 and remaining factor will be 1 is equal to B into A minus B. So b constant is equal to 1 over a minus b. Here we get the two values of constants a and b. Now put up the values of a and b in equation 3 of partial fractions. So equation will be 1 over a into a minus x into b minus x is equal to 1 over a minus b into a minus x plus 1 over a minus b into b minus x. So this is the equation after the partial fraction. It can be integrated very easily as compared to the initial equation, where the two different concentrations are going to be multiplied and different concentrations are multiplying, and integration of equation is not possible. Now in the partial fraction equation you can see that there are the two parts, one is a minus x and one is b minus x, but these are not multiplying, and the remaining part 1 over a minus b is a constant. It will come out of the integration. So we are going to integrate the equation. After integrating the dx over a minus x part and b minus x part, the remaining a 1 over a minus b is going to be outside the integration as a constant. So you can see that the after applying the formula of integration which we have learned in first order equation, that whenever we integrate 1 over x form into dx, it will give us the natural logarithm of that quantity. So result of 1 over a minus x will be negative log of a minus x, and 1 over b minus x result will be minus log of b minus x. So as a result, first a minus x minus log is going to multiply it with the minus sign of 1 over a minus b, and it will be converted into plus 1, and minus log of b minus x when multiplied with plus sign of equation, it will be converted whole factor into negative. Now we will take 1 over a minus b as a common factor. So result will be 1 over a minus b into log of a minus x minus log of b minus x. Now applying the log formula, simple log formula, equation will be converted into 1 over a minus b log of a minus x over b minus x. This is simple logarithmic formula that two things are written differently in subtractive form can be combined, written in a division form. So this is the final form of integration of left hand side of a second order reaction, where the two reactants have the different concentration. To complete the integration equation, we have to know the integration constant c. Now again same, put up the initial reaction boundary condition when time is equal to 0, product amount x is equal to 0. Now put up where x is present in the above equation is equal to 0, and similarly put up t is equal to 0. So kt is equal to 0, c will be equal to 1 over a minus b log of a over b. So c value which we have find, we can put up the c value in the final integrated form of equation number 8. As a result, the whole equation will be 1 over a minus b log of a minus x over b minus x is equal to kt plus 1 over a minus b log of a over b. So students, equation number 10 is actually a straight line equation. Again y is equal to ms plus c. We can plot a graph between the x-axis time as an independent variable and y as an dependent variable. The whole factor of left hand side will be drawn on the y-axis and temperature or time on the x-axis. As a result, straight line will be obtained with the intercept and slope you know can be find out by the tan theta is equal to rate constant k, and intercept is the whole factor of c 1 over a minus b log of a over b. Now students, we are going to rearrange the concentration terms on the left hand side to give us the another equation in the consolidated form. we have taken the C part to the left hand side, and after that we have taken 1 over a minus b factor as a common factor, and the final form of the equation after taking the common factor and the applying logarithmic formula is 1 over a minus b log of b into a minus x into divided by a into b minus x is equal to kt. So this is again a straight line equation. We can plot a graph between the time on the x-axis as an independent variable and whole factor on the left hand side on the y-axis, but here the straight line will pass through the origin with a zero intercept, and this slope can be found out as a rate constant k by the tan theta value. Now students, heading is example of second order reaction in a gas phase. So examples of second order reaction in a gas phase are the thermal decomposition of nitrogen dioxide to give us the nitrogen oxygen gas. Similarly, thermal decomposition of hydrogen iodide to give us the hydrogen and iodine. Thermal decomposition of nitrosyl chloride to give us nitric oxide and oxygen. And thermal decomposition of ozone to give us the oxygen gas are the examples of gas phase second order reaction. And second order reaction in solutions phase is when methyl iodide alkyl halide is going to treat it with the sodium ethoxide. As a result, ether will be formed. Unsymmetrical ether is going to be formed along with sodium iodide salt. Similarly, triethyl amine and ethyl iodide, when will react, it will form the quaternary ammonium salt with the internal charge, and formation of urea can be done by reacting the ammonium ion with the isocyanate ion. And lastly, potassium hypochlorite can be decomposed to give us potassium chloride and potassium chlorate. Thank you.